everyone. Welcome to our new series on MCQ questions in C programming. So for the next couple of days, we are going to be discussing on the questions based on operators. So let us go into the first question for today. What will be the output of the following code? So as you can see, the program and the options for this. Take a few seconds, predict the output. Okay, so now let us see what is the right answer here. So the right answer is option D, which is 255 and 9. So now let us try to understand how we got this answer. Right. So first let us execute the program. Right. So here I'm using an online compiler. So I'm just copied the program, whatever I have shown there, the same program is this. Now let me just execute it. So as you can see, the same output as what we predicted. So now let us understand how we got this output. So now before going into this, there are a few important points you have to pay attention to in this program. First, there is a keyword called as unsigned. So we have to understand what is the significance of this keyword. So in your C language, there are two keywords which plays a very important role. One keyword is called as signed and the other keyword is called as unsigned. Now, what do you mean by the signed and unsigned is, signed keyword is used to make sure that the value given to a variable can consist of both positive as well as negative numbers. So remember, so whenever we declare a variable as unsigned, so it is going to accept both positive and negative numbers. Accept both positive and negative values. Now, what does this unsigned mean? So unsigned is a keyword that is used to make sure that your variable can accept only positive values. So whenever you're creating a variable and you want to make sure that that variable will be holding only positive numbers, you don't want that variable to hold any negative values. So what we are going to do, we are going to make sure that we tag this keyword along. So unsigned keyword, it means only positive values. Done. So now the next question comes is, with what data types can I make use of this variable with this keywords? So remember, these two keywords, whether it is signed or whether it is unsigned, these two keywords can be used only with integers. Okay, so integers in the sense any form of integers, whether it is a short int or it is a normal int, or we are going to create a long int, or if it is a long int. So you know the different data types what we have, and also we can make use of this as char along with the char data type, because we know that internally your C language treats the char data type also as an integer, because it is going to work based on the ASCII values. We know that char is used to store a single character value. Okay, so how is that particular data type treated is based on the ASCII values. It is also considered as an integer only. So these are all the data types on which I can actually apply this signed and unsigned keywords. Right. So now let us take the first declaration. So it says unsigned char ch. So the name of my variable here is ch equals to 255. Okay, so now the next question what we have to ask is this a valid declaration? Because I just told you that char is a data type which is used to store a single character. So single character in the sense like I can give the values to store something like this. I can say char ch is equal to, within single quotes, I can store any single value, single character like this. Yes, it is possible. So it can be an alphabet, or I can say ch is equal to I can store a number like this, a digit, or I can say cat ch is equal to, all these are considered as valid. I can make use of any special operators, special symbols like this. So this is also valid. So as long as it is a single character, and that single character needs to be enclosed within single quotations. All these are valid statements. So now the question is, can I assign a value, a number for the variable ch? So to answer the first part of the question, yes, it is possible. So as I said, your char data type is internally treated as an integer for me. So this line is not going to create any compilation errors. No, there is absolutely no errors. It is valid. Now, the next important point, what we have to know here is, in C language, okay, in C language, every data type, okay, whatever is the data type you're creating, every data type occupies some memory space. That is, for me to store the value and keep, some memory is getting allocated for that variable. So whenever you declare a variable of the char data type, how much of memory it is going to occupy? It is going to occupy 1 byte of data. It is going to occupy 1 byte of memory here. Right. So 1 byte of memory means what would be the minimum value and what is going to be the maximum value that I can store inside this 1 byte. That is the next question you have to think about. Right. So what is the minimum and the maximum value that I can store within this 1 byte? Now, remember, this is an unsigned data type. So unsigned means, what did I say? It accepts only positive numbers. So when we are going to create a data type of an unsigned value, the minimum value that you can store is 0 and the maximum capacity of the data type is 255. So minimum value 0, maximum value 255. So this declaration is also valid. This value what I have given is also valid. No errors. Why? Because it can accept 255. So it is a good declaration. So when I try to print the ch value, the value stored inside this variable, it is going to give me the value as 255. So that is the first line of our output. The first print statement gives this. Superb. Now, the next thing what you have to do, I am saying ch is equal to ch plus 10. Okay, so what do you mean by that? I am saying ch is equal to, ch is a variable. What is the speciality of a variable? Values can keep on changing. Values can keep varying. That is the concept of my variables. So at this particular line, ch was holding the value 255. Now I'm going to change the value of ch. So what is the new value of ch going to be? So what is the value I am saying? I am saying ch plus 10. So the current value of ch is 255 plus 10. So what is the new value that you are going to be getting? The new value what I will be getting is 265. Right. So now the question comes is, I said the minimum and maximum capacity of a char data type. So 0 is the minimum value, 255 is the maximum value. Now this number 265 is something which is beyond the maximum capacity. So this variable can hold only this much, and I am trying to insert a data which is higher than that, more than the capacity of it. So whenever we try to do an operation like this, what is going to happen is my compiler will handle this in a different manner. So 265, it is not possible for me to store inside the ch as it is going beyond the capacity. So what is my compiler going to do is, it is going to apply some logic here. So what is that logic it is going to work on is, there is a formula, that is, whatever is the result you get, that result modulo. So remember, reminder operation is going to be performed. So modulo, what it is going to do is 2 to the power of n. This is how my compiler is going to handle it. So whatever is the final result you are going to get, that result modulo 2 to the power n. So now what is this n? Remember, n represents the number of bits. Number of bits. Okay, so now char occupies 1 byte of data. So 1 byte consists of how many bits? 8 bits. So 1 byte means 8 bits. So what does I say? Result modulo 2 to the power n, where n represents the number of bits. So apply this formula. What is the result we are getting? 265. Right. So 265 modulo 2 to the power of, okay, to the power of 2 to the power 8. So number of bits here, 1 byte occupies 8 bits. So it is going to be 2 to the power 8. So again, simplify this. So it is going to be 265 modulo. So what is 2 to the power 8 for us? It is going to give me 256. So do the division operation. So once you do the division operation, whatever is the remainder you are going to get. So remember, we are using a modulo operator. So a modulo operator is nothing but a remainder operator. So it is going to perform the division, and whatever is the remainder, it is going to return that. So when I divide 265 by 256, the remainder what I am going to be getting is 9. And this is the value that is going to be stored inside the CH. So the new data that my variable is going to be holding is 9. So next time, whenever I print the CH, it is going to give me the value of. So remember how it is going to happen when you go beyond the capacity of a particular data type. When we try to store the value beyond the capacity of that. Right. So remember, this logic is not only for the char data type. This logic is applicable for all my data types. Okay, so let us see another example here, a similar kind. Okay, so let me copy this program and I will execute and show you. Here, I'm using a short int. Right, so you know integer data type. So here I'm using a short int. So before that, let me just tell you, my system is a 64-bit machine. Okay, it is a 64-bit machine. That means int occupies 4 bytes of data and short int. Okay, short int occupies 2 bytes of data. So this is how the allocation is going to be done in a 64-bit system. Okay, so now my question is, again, I am saying unsigned. So again, I'm saying this integer variable x can accept only positive numbers. So what is the minimum and the maximum capacity of 2 bytes? So as I said, 2 bytes. So inside 2 bytes, how much of value can you store? So what is going to be the minimum? What is going to be the maximum? So remember, minimum value is 0 and the maximum value what I can store is 6555. So this is the maximum capacity of that. Yes, accepted. Now come back to our program. So when I say this, yes, it is valid because it is there within the range. So declaration and the assigning of the value is correct. So when I print, it is going to print me this value. So 65535 is going to be the first output for the print statement. Next, what am I doing? I am saying x is equal to x plus 20. So the current value of x, which is nothing but 65535. So the new value of x is what I'm saying, 65535 plus 20. So this is the new value that I am trying to insert into that. Right. So what is going to be my value? 55. That is the result. Okay. Now, what did I say? The minimum and the maximum capacity. So the result is going beyond the range. So what is going to happen? The same formula we are going to apply. So result modulo. Okay, result modulo 2 to the power of, okay, to the power of n. So now the n value is going to be a little bit different. So why is the n value different? Because here short int occupies 2 bytes of data. So 2 bytes of data means what? 16 bits. 1 byte is equal to 8 bits. So 2 bytes, 16 bits. So here what it is going to do? 65555 modulo 2 to the power of 16. So again, simplifying that, we are going to be getting 65556. So 2 to the power 16, this is the value you are going to be getting. So perform the division operation. What is the remainder you are going to get here? You're going to be getting a remainder of 19. You can work it out and check it. Right, so let me execute the program. So let us see what are the outputs I will be getting for this. Right, and see. Yes. So first time, as I said, 65535. Second time, it is giving me the output as 90, what we calculated. So whenever you get this type of questions, this is the logic we have to apply in solving it. Right. Thank you.